Today we're doing lesson 4 in module 5. This one still works on finding area of triangles, so you will find a lot of this review. On the opening exercise, it asks you to draw the altitude of the triangles. Now, altitude is not a word you've probably heard in math class before. You've probably heard it in other situations. Altitude you've probably heard of in terms of somebody talking about an airplane and the altitude, or in the mountains, someone talking about the altitude. So altitude is a synonym for height in math. So we're looking for the height. So if we look at the first triangle, okay, this is similar to what you did in lesson 1 with the parallelograms. I need to find the height of this triangle. So in order to find the height, first I have to recognize where my base is. So I decide which side I want to be my base. So if I decide that this side is my base, then I need to draw an altitude or a height that forms a right angle with that. So in this triangle, take from the furthest distance from it, and I draw myself a dotted line, and then put my box to show my right angle. And that is my altitude or my height. Okay. In the second triangle, I need to show an altitude, so I decide which side I want to use as my base. Now, recognizing that I already have a right angle here, I can choose one of two sides to be my base, and then the other side forming the right angle to be my altitude. So if I make this my base, then that means this side over here becomes my altitude. But I could correctly answer it and reverse those and put the base where the altitude is and the altitude where the base is, because those two dimensions form my right angle. The base does have to be one of my outside edges, but the altitude can be an outside edge if I have a right triangle, or it can be a dotted line inside or outside of my triangle for the altitude or height. Right. In triangle C, this is what we call an obtuse triangle because it's got an obtuse angle in it. So first I identify which side I want to use as my base. So if I make this side my base right here, then I want to go to the very top part, and I need to draw a straight line going down. And since it doesn't touch the base, I would make a line going across here and put my box there. And so this side over here, that dotted line there is my altitude or my height. Okay. Now if I'm using those to find the area of the triangle, those would be the two measurements that I'm using. Okay. If you look at the bottom of this page, it has an exploratory activity. We're not able to do that activity because you don't have the cutout triangles that go with that. So from this point you want to move forward to problem 6. All right, so here we are on problem 6. Okay, so problem 6 through 8. So we are continuing finding area of triangles. Area of a triangle, remember, is 1/2 times the base times the height. The base has to be an edge of the triangle, so I'm looking for where the right angle is. And so I'm looking, here's my base. My base is 24. I do not add the 6 to it because the 6 is not part of the actual triangle. Sometimes it is helpful to shade in the actual triangle to help you see it. Okay, so if I do that, you can see that my base of the triangle is 24 and its height is 8. So for this one, area equals 1/2 times a base of 24 times a height of 8. So then you grab your calculator and you multiply those together. So find your calculator. And when I multiply those together, I get 96. So the area equals 96 inches squared. Okay, look at the next one. I want you to identify what two numbers you're going to use for your base and your height. While you're doing that, I'm shading in the actual triangle to help you figure out where they are. Okay, so I'm going to use this as my base and this as my height. Okay, so area equals 1/2 base times height. So the area equals 1/2 times 12 3/4 times 9 1/2. Okay, so grab your calculator, plug that in. And you get 60 9/16 feet squared. Hi. For our next problem, it asks you to draw 3 triangles, an acute triangle, a right triangle, and an obtuse triangle that have the same area, and explain how you know they have the same area. So the simplest way to do that is to draw them so that they all have the same base and the same height. So when I draw an acute triangle, that means all 3 angles are less than 90 degrees. Okay? So the simplest one to draw is an equilateral triangle. All 3 angles, if I were to measure them, are smaller than a right angle. And I label my base. I'm going to just use 10. So say my base is 10, and I can choose whatever label I want. And then I draw in a line to show my height, and I pick a number for that. So I'm going to say 8 inches. Okay. Now I need to draw a right triangle. So first thing I do is I draw my right angle right there, and then my base and height, 10 inches and 8 inches. So remember, if they all have the same base and height, then they will have the same area. Okay, so then an obtuse one, so I draw my obtuse angle, draw my line connecting them, make my triangle. So this angle right here is obtuse. It is bigger than 90 degrees. 10 inches, and then I have to draw in my height, and with an obtuse triangle, that's going to always be on the outside, and then that is 8 inches. So in doing that, I've given them all the same base and the same height, and so when I calculate that, area equals 1/2 base times height. So area equals 1/2 times 10 times 8. So when I multiply that, I get 40. So my area is 40 inches squared. Hey, you're all set. You can start on your problem set.